We'll now walk through H2O's core data science capabilities in the data science and machine learning techniques specifically for automated machine learning. We're going to start back in Driverless AI where we just finished our data prep. Here we can automatically build tabular and time series datas, and we also have a wizard-based UI for our business unit or business folks on Fusion teams. We'll look a little bit at interpretability and how we understand our results and how the model is working. And then we'll look at a new capability from H2O that is chat for data science called H2O Functions. And we'll do some of the same functionality that we've done earlier in this demo, but from a chat-based interface. So now we're back in Driverless AI and we have our data set that we've split ahead of time. So I can start with a standard flow for data scientists, which we're also able to do from Python API, which is predict. Here, I'll go ahead and say what I'm trying to predict, which is whether or not someone's going to default next month. And now some settings have been chosen for me automatically. As the expert on this data set, I can choose what's most important for this business case. Do I care about being able to explain the results to regulators or business leaders? I probably do for this specific use case. But in other cases, maybe interpretability is less important and accuracy is what we want to exemplify. As I change these, the plan on the side that explains what we're going to try, the algorithms, the feature engineering, how we massage the data, will all update. I can go ahead and kick off this experiment with any expert settings around the models or data prep that I want to do, or I can create a leaderboard. If I do a leaderboard, it will automatically, instead of me having to choose the accuracy, time, interpretability, it will automatically kick off 10 different jobs for me with different calibrations and levels of accuracy, interpretability, and different algorithm types like a constant model versus GLM versus a torch or deep learning model. So all of these are automatically queued as needed, and the resources that I've allocated to this machine for this use case will be used over time. All right, let's go back to a completed experiment. Actually, let's go back to our data sets and think about the workflow for a not so technical user who maybe doesn't know what the expert settings mean or even how they would choose if they needed interpretability or not. And for this, we're going to go to the predict wizard. In the Predict Wizard, we start by sharing some information about ourselves. What is our persona? And here we can say that I'm a domain expert. I really know my industry, but I'm actually pretty new to data science. I've been here less than a year. And based on what I say here, the questions that I get will change. So first, it's just like in our data science-based UI, what are we trying to predict? But we're giving the user a little bit more information to help them make this decision. And I want to predict who will default next month. We can see automatically that we don't need sampling. It understands the size of our data. And we can see that it thinks this looks like a pretty good distribution. So I don't need to do any imbalanced sampling of my data set or anything like that. So we're still doing the same steps as normal, but Driverless AI is walking us through how to set up the experiment and a lot of the steps that it would do automatically to help us really learn, collaborate, and understand how to build these models. So we found an ID column, we're going to have it drop it automatically, and then I can say how involved I want to be, but I'll let it look for any columns to drop. So automatically get checks for leakage, see who is too predictive or who's not. So the wizard will walk us through many steps to help us work through and build our models. All right, let's go back to a completed experiment. We can see our leaderboard is still working, but the first couple models in it are almost done. Our constant baseline model has an AUC of 0.5, which is exactly what you'd expect from a constant baseline, but some of our more decision tree-based models are doing pretty okay. All right, let's go ahead and look at a model we built ahead of time. So in this view, our users can understand how the model was built, how many models were tried, algorithms, and engineered features. For the most part, this model used default features straight from the model, but it's possible that we could try adding a couple of the pays together or other automatic feature engineering that would be handled for the users, giving us a little bit extra data prep. When we're ready for this model to be in production, we get all of that feature engineering in our model pipeline automatically. All right, we now want to understand how the model works. So we'll go to Show Most Recent Interpretation. And here I get explanations, mostly from a technical perspective, that allow me to see how things are working. So if I go to Shapley values, I can see the most important feature in my data set that's contributing to predictions is pay 0. From a little bit more of a business perspective, we can check out partial dependency plots. Here in partial dependency plots, we can see how changing the value of a specific feature would change predictions. So for example, the values of pay zero that are quite low have a pretty low likelihood to default on their payment. Whereas if the value of pay zero is quite high, they're more likely to default on the payment. We can see the distribution of our data, so this doesn't happen very often, but here we can start to see a business insight. Although not a lot of our end users are in this bucket, those that are maybe are likely to default.